In this lesson, we're going to continue to look at ions, and we're going to learn how to predict the charges on ions formed from the representative elements. As we've seen before, neon as a noble gas has stability associated with it. Ions are going to gain or lose electrons to form an octet that gives it a stability similar to that of the noble gases. So when we look at these elements, such as oxygen and fluorine, we see that they have 6 and 7 valence electrons respectively. They are going to gain electrons in order to get to 8 valence, and as a result they're going to form anions because they are gaining electrons. Sodium and magnesium have 1 and 2 electrons in their valence shell, and they are going to lose electrons to form an ion, in this case a cation, that looks like neon. Notice that sodium and magnesium could theoretically gain 7 and 6 electrons rather than losing 1 and 2, but it's going to be much easier to lose 1 electron for sodium than it is to gain 7. Likewise for fluorine, it's much easier for it to gain 1 electron than to lose 7 to look like the previous noble gas. So oxygen will gain 2 electrons, as will other elements in that column. Fluorine will gain 1 electron to form its anion. Sodium will lose 1, and magnesium will lose 2. And this trend follows just like the valence electron trend. What one element does in a column, all the other elements will do as well. Previously, we talked about the comparison between the number of valence electrons of elements in the same column, and we saw that they had the same number of valence electrons. As a result, we're going to see that they also form the same charge, because lithium, sodium, and potassium all have 1 valence electron. In order to look like the nearest noble gas, they're all going to lose 1 electron, which means they're all going to form a cation with a +1 charge. So when we look at the periodic table, we're going to focus on our main group elements, which are the first 2 columns and the last 6 columns. The transition metals in the middle behave a little bit differently, and they're not as easy to predict the charges, so we're focusing on the main group or the representative elements. And we see that everything in that first column is going to have a +1 charge when it forms an ion, because all of those elements have 1 valence electron. Next, we're going to look at the second column, and we see that these elements all have 2 valence electrons, and they're all going to lose 2 electrons and form a charge of +2. When we move to the other side of the periodic table, for example, looking at fluorine, we see that it has 7 valence electrons. It's going to gain 1 electron in order to look like neon, so it will have a charge of -1. All of the elements in that column, which are known as the halogens, are going to have 7 valence electrons. They're all going to need to gain 1 electron to look like the nearest noble gas, and as a result, they will all have an anion charge of -1. We can also look at oxygen, which has 6 valence electrons. In order to look like the nearest noble gas, it's going to gain 2 electrons and will have a charge of -2. Likewise for sulfur and selenium and the other elements in that column. So we'll have a -2 charge on ions formed from those elements. For the next column over, when those elements form ions, they will have a charge of -3. We typically do not see ionic compounds forming from carbon or elements in that column, so you're not going to need to worry about what charge carbon would take. We may see compounds form from aluminum or gallium, and those would have a +3 charge.